Hello friends, welcome to Roots Smart Class. I am Sachith. I am your guide for science. In science, today I am taking up chemistry, where in chemistry we will be studying the chapter chemical reactions. So as you all know, in our surroundings we have lot of things to see. We have substance, we have objects. So these objects and substance are made up of very tiny particles. So these tiny particles in our modern chemistry we have names. We have atoms, molecules, we call it as elements, we have term called molecules, we call it as compounds, we call it as ions. So you must be wondering from where the names or terms have originated, right? So let's go to ancient history. So in ancient history, we have Panchatattva elements where 5 elements were considered to the matter composition. What are those 5 elements? Wind, water, fire, earth and sky. So in 500 BC, there was an Indian philosopher, Maharishi Kannada. He was the person who told that the substance, when you divide into a smaller particles, that is very tiny particles, he named it as a anu or paramanu. So that is basically atoms or molecules. So these atoms and molecules was the name given by Democritus in 5th century. So he gave a name for this indivisible particle that you call it as atoms. Later, John Dalton, he elaborated and he proposed a model and also atomic theory where he proposed that the atoms of the elements are same. The elements which is present and those atoms are same. He also said that the different elements have different atoms. So those different atoms will have mass and also size. That means the different elements will have different number of atoms, that is different number of electrons, and different element, other element will have its own number of electrons. Fine. After John Dalton, Rutherford came up with a model, and that model was like this: a nucleus, and around the nucleus the electrons were orbiting. So this is what Rutherford said: the electrons are orbiting outside the nucleus at some distance. After Rutherford, Niels Bohr, he also proposed a Bohr model, and he said that in an atom you have a nucleus, and outside the nucleus you have a ring like structure or orbit, and he named it as shells. He named it as shell or energy level. He called it as energy level. So this is how from our history we have got these terms. So those terms are atoms, molecules, elements, compounds and ions. Now it is very much important to understand what are these terms to understand the chemical reaction. Fine. So when I am explaining a chemical reaction, and when I say element, when I say compound, so you should be very clear. Sir is talking about element and what is its characteristic, and sir is talking about compound, what is its characteristics. When I am talking about ions, what does ion mean? So you should be very thorough. So when you understand all these terms, it will be very clear for us, and also it is very easy for us to understand the chemical reactions. Fine. Let's start with it. So first is atoms. So in this slide you can see there are 4 examples. In the first example you have a rock here, you have a smoke or a gas, I can say, there is a water and there is a chair. So from our lower classes we've been studying that matter is made up of very tiny particles, and this matter is classified into 3 forms, that is solid, liquid and gas. So how do we classify this? Based on the atoms arrangement, right? Based on the atoms arrangement we classify these matters. So rock, when I talk about rock, we know this rock, obviously it is made up of very tiny particles, but these tiny particles are combined together or fused together so tightly that it is in the solid form. But there are trillions and millions of tiny particles which is present here. Fine. Same it goes for smoke or a gas. So as we know, in gas we have atoms, and those atoms are not very strong. They are free to move, right? So even the smoke or a gas is made up of very tiny particles, but those tiny particles doesn't have a very strong bond. When it comes to water, again, this water is made up of tiny molecules or atoms. These atoms are not so strong when compared to solid. Okay, these things you have studied in your lower classes. I'm just revising it. So chair also, it comes under solid. Fine. So you understood what is atom. So atom is something where the tiny particles, when they combine together, they form a substance. So those tiny particles are nothing but atoms. Okay, let me give you an example. You have your kitchen, go to kitchen, from your right hand, take a pinch of salt powder. From your left hand, you take a stone salt. Fine. Now place it somewhere on the plate or wherever you are comfortable. Now try to separate the grain. You have to separate each grain, that is the salt, the stone salt and also the powder salt. You start separating it and make it a single grain. Now you might have done it. Now crystal. In stone salt you have crystals, and it is very easy for you to pick it up, right? Because it is, the size of the crystal is small. Though the salt is same, the composition of the stone salt and the composition of this powder salt is different. So here you have crystals, and here you cannot pick, that is in a powder salt you cannot pick each grain. Why? The size is very small, you cannot pick it up. But when you press that particle, it will get stuck in your finger, right? Now you can compare the size of the atoms. Fine. So in this crystal, it was very big, and when it is salt, it was very small. There are particles which is very tiny. For example, dust. When you start hitting the mat, the dust particles will go down, right? You can see the dust particles moving down and settling in the bottom. When do you see these dust particles? Only when the light is falling on that particular dust particle. You might have experienced, you see a path of light coming from a window, and in that path of light, the particles, the dust particles are moving around. So those particles, we never thought that it is present. Only when there is a light, a path of light falling on that dust particle, we found that okay, these are the dust particles which is moving around. So you can imagine particles are so tiny that it is not visible through your naked eye. Okay, so that naked eye, we say that the tiny particle, further it cannot be divided. Such tiny it is. Fine. So this is about atom. So at the beginning, as I said, in our surroundings we have lot of substance, we have lot of object items. So we see around. Fine. So those objects are made up of tiny particles, right? So these substances are classified into two. That is, one is elements and one is compounds. So what do you mean by elements and what do you mean by compounds? It's very much important to understand, because in the further concepts we will be studying about chemical reaction, handling, balancing of chemical reaction, or converting the word equation into chemical form. So when I'm going to explain this is an element, this is a compound, you have to be very thorough with the concept. That is, you have to be able to differentiate which is the element and which is the compound. Fine. So as you can see, in a short form I have written, the elements is nothing but a single type of atom. Compounds is a different type of atom. So let's understand in a better way through examples. So elements, you have set of examples over here. So here you have a nail, and this nail is of iron. So iron symbol is Fe, and you have a sheets here, and this sheets is aluminium sheets. This is a chlorine. This is chlorine, Cl, and this is bromine, Br. Fine. Now let me explain you what is element. So I consider this nail. So now what I'll do is I'll take out two atoms from this elements. Fine. From this iron element I'll take out two atoms. This is hypothetical. This is not happening in real, but just to make you understand, I'm telling you that I'm taking two atoms or 3 to 4 atoms from this iron nail. So what I'll do is I'll start comparing this iron nail. Whatever atoms I've taken out from this nail, I'll start comparing it. So what I see is the atoms which is on my right hand and the atoms which is on my left hand look similar. Why? Because I'm taking the atom from the same element. So the element which is, the atom which is present in this particular element is same. So throughout this nail, whatever shape it is, the atoms which is present in the nail is of same element, that is iron element. Clear? Let's go for aluminium. It goes same. So in the aluminium sheet, I'll cut a small piece of it. I'll try to take out two atoms from it and I'll try to compare. When I try to compare, the atoms, maybe the size or the shape looks similar. The two atoms look similar. So then I can say the atoms which I've taken from aluminium, it belongs to aluminium element. Fine. It goes same for bromine and also chlorine. Now, when I say Fe, it is understood that it is element, iron element. Aluminium, Al. So it means it is aluminium. Fine. Cu is what? Copper. O is what? Oxygen. N is what? Nitrogen. So these are the symbols to represent different elements. So when I write just a symbol, what does it mean? It means I'm just talking about one atom. I'm just talking about one atom of iron. I'm talking about one atom of aluminium. I'm talking about one atom of copper, one atom of nitrogen and one atom of oxygen. So here there is a new term coming into a picture. We call it as molecule. We call it as molecule. So let's understand what is molecule. So basically molecule is something where you group an atom of same type. Okay, in elements there are atoms, lot of atoms is present in a element. So if I group those atoms, I call that as molecule. How? I'll explain. Bromine. Bromine in nature, it exists in the form of Br2. So bromine is a liquid, chlorine is a gas. Chlorine is a poisonous gas. Okay, so Br2. So here Br is what? An element. What does this 2 represent? 2 represent that atoms of bromine, 2 atoms of bromine, they combine, they fuse or they come together to form one molecule. So this pair of atom, you call it as a molecule. Clear? So what is molecule? Molecule is something where you combine or fuse the atoms of that particular element. See, Br2. So I have, if I write Br, it is only one element, right? If I want a molecule, it's not like if I want a molecule, this bromine is present in this form. It is in the form of Br2. That is bromine 2. So bromine is an element. 2 is the pair of atoms which is being combined, and that combined atom, I call it as a molecule. Fine. Similarly, we have Cl, that is chlorine. Even chlorine in the nature, it exists in the form of Cl2. It never exists in one atom. It exists in the form of 2 atoms, that is pair of atoms, right? That is Cl2. So here Cl is what? It is element. What is 2? 2 is 2 atoms of chlorine which is being combined together, and this 2 atoms I call it as molecule. That is, so Cl2 is what? Cl2 is a molecule. That is one molecule of chlorine. If I tell Br2, it is one molecule of bromine. There are few more elements which exist in this form. One is oxygen. Oxygen is always, it is in the form of two atoms combined. Okay, pair of atoms which has been combined, and we call this as oxygen molecule. We call it as oxygen molecule. Along with that, you have nitrogen. Even this is a molecule. In the nature, it exists in the form of two atoms, that is pair of atoms, and I call it as that pair of atoms as molecule. Fine. There is one more, that is O3. What is O3? O3 is O3, that is oxygen which is present in ozone layer. Okay, this is a ozone layer air. So here you can see O3. So in ozone, the oxygen is having 3 bonds. Okay, it is having 3 atoms and it is combined together, and that combined together of 3 atoms we call it as what? Molecule. We call it as molecule. Clear? So we are talking about elements. So as I said, elements means in that elements the atoms which is present is of same type, and one point you have to remember here is all the elements will not form molecule. In our examples only we have understood, right? See, iron, it exists in one atom. Aluminium, it exists in the nature in the form of one atom. While coming to bromine and chlorine, it exists in the form of 2 atoms. So that we call it as molecule. So what is my sentence? My sentence is all elements will not form molecule. Okay, all elements will not form molecule. So this is about elements. Now we will understand what is compound. So once we study what is compound with an example, then you will be able to differentiate between elements and compound. Fine. So there are a set of examples. So this first example is a calcium carbonate. Calcium carbonate. So calcium carbonate is nothing but limestone. Okay, this is nothing but a limestone. So here it is, you have water, and you have sodium chloride, that is your common salt, sodium chloride. Fine. Now, when I am explaining this compound, there is one more term which comes into picture, is chemical formula. That is chemical formula. So now what is this chemical formula? So basically this chemical formula tells me in a compound, what are the elements present in it. So what does my chemical formula will do? So chemical formula will tell me that what are the elements which is present in a compound. So calcium carbonate, I have given you example that it is a compound. So if I have the chemical formula for calcium carbonate, I can able to understand or identify what are the elements which has formed this compound. For example, water. So water, it is a compound. Why? Because 2 or more elements have combined together, then this compound of water is formed. Similarly, sodium chloride. So let's write the chemical formula and we will understand in a better way. So for calcium chloride, it is CaCO3. CaCO3. So now am I able to identify what are the elements? What are the elements? Ca, that is calcium. What is C? C is carbon. O is oxygen. So now you can go back to our previous slide. See here, compound means what? It is a compound means in a compound you have different types of atoms. So different types of atom means you have different elements. Is it true? It's true, right? Because you have a calcium, it's a different element. You have carbon, you have a different element. Oxygen, it's a different element. So CaCO3 is a compound. So with the chemical formula, I am able to identify that in a compound there are different elements. So let's go for water. You know the water chemical formula is H2O. So here I am able to understand and I am able to identify that there are two atoms. One is hydrogen and one more is oxygen. Fine. Let's come to sodium chloride. So sodium chloride is NaCl. Na is what? Sodium. Cl is chlorine. Fine. You understood this part? Perfect. Now how this compound is considered as a molecule? How this compound is considered as a molecule? So as you see, Ca, one atom. So one atom of calcium, one atom of carbon, that is like this, and three atoms of oxygen. So they are combined together like this. So this full, I call it as molecule. Molecule of what? Compound. Okay. So basically, molecule is nothing but combining of atoms. It can be a different atom. If it is combining of same atom, you call it that as element. Clear? Molecule, if you are combining two or more atoms of same type, then you call it as element. If you are combining atoms of different elements, then you call it as compound. Clear? So here also in water, when it comes to water, how many atoms you have? Two hydrogen atoms, that is two hydrogen atoms will combine with one oxygen atom, something like this. So here you have sodium one atom, chlorine one atom, together they form what? Molecule. So this molecule is called as compound, not element. So is it clear? Fine. So again in this compound you have to remember one point, that is all compounds will form what? Molecule. The all compounds will form molecules. In the previous slide I had written this point that all elements will not form molecule. Why? Because all the elements is not in the form of, it won't exist in the form of one atom. Correct? So when it comes to compound, all the molecules, all the compounds, see this is a compound, this is a compound and this is a compound, can form molecules. Why? Molecules is nothing but group of atoms. It can be a different element, it can be a same element. So but all the compounds will form molecule. So this point you keep it in your mind. So next, coming to ions. Ions, so in your lower classes you have studied that matter is made up of again a tiny particle. That tiny particle is nothing but atom. So in your lower classes you have studied that atoms has three particles. What are those? Electrons, protons and neutrons. So these three particles have its own charge. So electron is negative charge, negatively charged, or protons is positively charged, and neutron is neutral. So we don't have any charge for neutron. Fine. So when we have charges for these three particles, obviously we have to calculate for the atom. That we call it as total charge, or you call it as net charge. Correct? So when you have charges for these particles, obviously this atom will be having its complete charge, right? The total charge, or we call it as net charge. Okay, that is what we are discussing now. Okay, let's explain. Let me explain with an example. So I consider an element X. Okay, just an example. I consider one element X, and that in that element you have an atom. In that atom I have 5 electrons, I have 5 protons and few neutrons. Fine. Now electrons are negatively charged, protons are positively charged. Now if I want to take the net charge of this atom, if I want to take the net charge or the total charge of this particular atom, what I have to do? Total charge, that is 5 electrons, 5 protons. When I do total charge, obviously it is going to get cancelled because the number of electrons is equals to number of protons. Always remember this. Okay, in an atom the number of electrons is equal to number of protons. So when this is the condition, the net charge will be 0. Correct? So the net charge of an atom is 0. When the net charge is going to be 0? When the number of electrons is equal to number of protons. Clear? Fine. So let us take the same example. I have 5 electrons, 5 protons and few neutrons. So now somehow I try to add one electron to this atom. Okay, this is an element. So to that element, to that atom of the element, I try to add one electron. So what happens? It gets converted like 6 electrons, that is addition of 1 electron, it becomes 6 electron, 5 protons. So when you find the net charge of that particular atom, what do you get? -1. So what is this? -1 is the net charge, of this particular atom where the electron is added. Clear? -1 is the net charge of this atom where the electron is being added to this atom. So we call such atom as negative ion. You call it as negative ion. For example, if I add 2 electrons instead of 1, if I add 2 electrons, what is the net charge of this particular atom? It is -2. So what does this mean? This means if the net charge is -2, then it means that the atom has got added with 2 electrons. Okay, when 2 electrons is added, the number of electrons is going to exceed. That's how you get -2. That atom you call it as negative ion. So basically you have to understand that the electrons, when you add it to an atom, so that atom will have excess amount of electron. Correct? So see here, you have 5 electrons and 5 protons. You try to add excess of electrons to that particular atom. So what happens? Excess of electrons will be present in that whole atom. So that whole atom will have net charge of -2, that is excess of electron. So that excess of electron, when you get it when you add. So when you add the electron, so that atom you call it as negative ion. Clear? So let's understand what is positive ion. Similarly, same example, one element, and in that element you have 5 electrons, 5 protons and few neutrons. So here what I'm trying to do is I'm trying to eliminate one electron from this atom. I'm trying to eliminate one electron from this atom. So what happens? So when an electron is being eliminated or transferred to some other element, so this atom will have only 4 electrons and 5 protons. So when you total charge it, what you get? You get plus 1. You get plus 1. So this is your net charge for this particular atom. So what does this mean? This means that when an electron is being eliminated from particular atom, so this net charge becomes positive. Why? There is a deficiency in electron. When you take out this electron, we say there is a deficiency in electron. When you add the electron, you say there is an excess of electron. So such type of atom where electron is being eliminated, you call it as positive ion. You call it as positive ion. Very much clear? Same example, let's do with 2 electrons. You try to eliminate 2 electrons. What happens here? The deficiency of electrons will be plus 2. So that means 2 electrons is being eliminated from this atom. So you have deficiency of how many atoms? Sorry, deficiency of how many electrons? That is 2. Fine. So this is what? This is the atom where we call it as positive ion. Clear? Fine. So these are the terms you have to be very thorough with, so that the chemical reactions, when we start studying that chapter, it will be very easy for you to understand. Fine. Okay, coming to the last part, here we have a picture where you have to find whether it is a physical change or a chemical change. So in the first example, you have a boiling of water. So in this boiling of water, can you tell me whether is it a chemical change or a physical change? In the first example, it is understood that it is a physical change. It is understood as physical change. Why it is a physical change? See, when you boil the water, what happens? The water which is in a liquid form, it gets boiled and it gets converted into water vapor, so into a gaseous form, right? So here the state of matter, that is the state, the formation of state is different, that it is converting from liquid to gaseous form. So state is different, so it is a physical state. Coming to the second example, you have melting of ice. So melting of ice is solid to liquid. Again, this is the best example for a physical change. Burning of candle. Okay, burning of candle we will discuss later at the end. Coming to the cooking part. So you have cooking. What type of change it is? It is chemical change. Why do we call it as chemical change? See, when you start cooking, you put chili, raw chili, you put tomatoes, you put onions, you put potatoes. So you start cooking. When it starts boiling, you get one dish. Can you make that dish? Can you reverse that dish and get the potatoes back, the onions back, and also the tomatoes and chilies back? Can you do it? It's not possible, right? So we call this as chemical change. So why do we call this, on what basis we call it as chemical change? Chemical change is something where chemical reaction is taking place. So when chemical reaction is taking place, you get a new product or new substance, where the new substance has new characteristics or new features. Fine. So that is how we call it as chemical change. Okay, because we cannot reverse the process and we cannot get the same product when you reverse it. Fine. Coming to the last part. So last example, you have rusting of iron. Again, it is a chemical change. Why this is a chemical change? You expose this iron in atmosphere. So what happens? Rusting starts, or we call it as corrosion. So corrosion is basically a layer is formed when an iron gets reacted with oxygen. So obviously it is a chemical reaction, because you find a chemical change, because before it got rusted, before this layer was appeared on the chain, it was proper iron, right? Proper iron with shining iron. So when it got exposed to air, what happens? A layer is being formed on the chain. So this is a chemical reaction and this is a chemical change. So chemical reaction is happening and we got a new product, that is corrosion, that rusting is called a new product. Fine. So coming to the last, that is a candle. So what type of change it is? Chemical or physical? It is physical and also it is chemical. Why? See, wax is in a solid form. So when you burn the thread of the candle, what happens to that solid wax? It starts melting. The molten comes out, right? So it comes down to the bottom, it settles down. So that state, the change of state, you call it as physical state. Okay. What about chemical? See, when you lit up the thread of the candle, the light or the fire comes out because it is being reacted with oxygen. So that's when the fire is being generated. So this fire is being converted into, again it gets converted into carbon dioxide because it uses oxygen and it gives out carbon dioxide, and along with that it gives out water vapor. Okay, it gives out water vapor. So that is the reason we consider burning of candle as both, it has both physical and chemical change. Fine. So in this chapter we have studied terms like atom, elements, compounds, molecules, ions. So these terms are very much important so that you can understand the chemical reactions in a better way, right? So in the next session we will be studying about chemical reactions, how the chemical reactions, that is from the word equation, how do you write it in a chemical form, and also we will be studying about the balancing of chemical reactions. We will be studying about the types, different types. We have 5 different types. We will be discussing about those different types of chemical reaction. Hope you are able to differentiate between all the terms, that is atoms, molecules, elements and compounds and ions. So till then we'll see you in the next session. Thank you. This is Sachith signing off.